All right, welcome back to Linear Analysis. In this third video, we are going to focus on modeling with linear functions. So much fun. So here basically we're talking about word problems, right? Taking real world situations and modeling them with linear functions to help us better understand them. Modeling with functions is one of the most important things you could possibly learn in this class. And we're going to learn how to model with all different types of functions. And the easiest ones, not going to lie, are linear functions. This shouldn't be too bad. So here's our first problem. A town's population has been growing linearly, which means it's growing at a constant rate. That's what linearly means, right? We learned that. In 2004, the population was 6,200. By 2009, the population had grown to 8,100. Assuming this trend continues, predict the population in 2013 and identify the year in which the population will reach 15,000. All right, so the first thing we have to do here is we got to create 2 points. We know this is linear, right? So we know we're increasing here. So we need to find 2 points on this population trend line. So the first point we know is 2004. The population was 6,200. 2009, 8,100. Now what I'm going to do is I'm going to let 2000 basically be the beginning. So it's just going to make the numbers a little bit easier for me. So the first point is going to be year 4. So we're going to have like 2000 represent x equals 0. So, for lack of a better explanation here, we're going to use the beginning of time as 2000. So in year 4, the population was 6,200. Now, by the way, you don't have to do that, but it does make the math a little bit easier. And then in year 9, the population was 8,100. So now we have to first find our rate of change. I know you guys call that slope, but I like to call that the rate. So that's going to be subtracting our y's on top, 8,100 minus 6,200, and divided by subtracting our x's, 9 minus 4. All right, so this shouldn't be too bad. So on top, we get 1,900. And in the bottom, we get a 5. Divide that out, we get 380. So what does that rate of change tell me? It tells me for every year after the year 2000, we increase our population by 380. So that's our constant rate of change, 380 people per year. Got to make sure you can explain the numbers with words when you're modeling. All right, now we need to create our equation because we still haven't found the actual equation yet because we need an equation to do the predicting. So remember, I am in love with point slope form. So we have a slope, 380, and we need a point. You can actually pick either one of them. I'll choose the first point. So it's going to be y minus the y coordinate of 6,200 equals the slope, 380, times x minus the x coordinate of 4. Now it's got to do a little bit of math, a little bit of distribution here, a little bit of algebra. So we get 380x. 380 times 4 is negative 1,520. And then we got to solve for y by adding the 6,200 over. None of this is very difficult math. So we get 380x plus 4,680. So that y-intercept is what the population would have been in year 0. So if I plug a 0 in for x, I'd get 4,680. That would be the year 2000. And then again, the slope is what we increase by every year. So now I could use that equation to find the population in the year 2013. Now remember, don't plug in 2013. We're plugging in 13 because that's 13 years after 2000. And you guys can grab a calculator to do that math. It's not too bad. We should get a population of 9,620 people. Okay, so that was the answer to our first question. Predict the population to be 9,620. Now this next question says identify the year in which population will reach 15,000. So now we're working backwards. So this time we want to solve for when the population is 15,000. So we're solving for x, the number of years after 2000, when we will essentially reach that population. So now I got to subtract 4,680 from both sides to get the cancel out on the right. And I get 10,320 equals 380x. Divide both sides by 380. On the right side, 380 divided by 380 is 1, so it reduces to just a plain old 1x. And we get, if you use a calculator, 27.158. So remember, that is 27.158 years after 2000. So sometime in the year 2027, we will reach a population of 15,000. So it won't be be somewhere towards the beginning of the year, right? 1.158. So a little bit after 2027, we will hit that population. All right, so hopefully that makes sense. Not too bad there at all. Pretty easy, right? All right, here's another one. A company sells donuts. They incur a fixed cost of $25,000 for rent, insurance, and other expenses. And then they also cost them 25 cents to produce each donut. Write a linear model to represent the cost of the company as a function of X, the number of donuts produced. So we're trying to find an equation for the cost. So this $25,000 is a fixed cost that basically we have to pay that all the time, right? Maybe this is every month. We have to pay rent for our building. We have to pay insurance. We have to pay our employees. We have to, make sure everything's ready to go. Marketing, maybe, right? That's all that money that's like a fixed cost. I mean, it's not going to change per month. Then we're going to add the fact that every single donut costs us 25 cents to make. So if we make one donut, then we're going to have $25,000 in fixed costs plus that extra 25 cents that one donut. So again, the number of donuts changes, and donuts require flour, sugar, and all those other ingredients that go into the donut. So that's that 25 cents per donut. And together, this is going to be our total cost. All right. So that's pretty simple. It's really easy, right? Then it says find and interpret the y-intercept. So basically the y-intercept right here of 25,000 is what happens when x equals 0. And that basically tells me that if I don't sell any donuts, I don't make any donuts, so I don't have to produce any donuts. Well, I still have to spend that $25,000 for rent, insurance, and other expenses because that money's going whether I sell any donuts or make any or not. Pretty simple concept. All right, here's another one that's actually pretty fun, not too bad as well. Suppose that the relationship between the price and quantity of widgets sold is linear. So a widget is just my made-up word for a product, right? So the relationship between the price and the quantity of products sold is linear. So the price is $23. We can sell 4,783 widgets. So if I charge $23 for my product, I will sell 4,783 of them. However, if I increase my price, if I decide, hey, I'm gonna sell them for a little bit more to $27, well, then, what happens when you charge more money for something? Less people buy it because it gets to be too expensive. So if I charge $27, I actually will only sell 4,295 widgets. So it does say it's a linear model. So that means that it's a constant rate. So the more I charge, the less widgets I'm going to sell. That's just marketing economics 101 there. So find a function that models the number of widgets sold based on the price of the widget. All right, so first thing I got to do is find that rate. Very simple to do. 4,295. That's my y minus the other y, 4,783, divided by subtracting the x's in the same order, 27 minus 23. All right, this isn't too bad here. So in my numerator, I get negative 488. In my denominator, I get 4. Divide that out, we get exactly negative 122. So that's my rate of change. That means for every $1 I up the price of my widget, I'm actually going to sell 122 less of them. That's a pretty big change there for every $1 extra. So now the thing I got to do is got to create that equation, right? So to create the equation, you guys know my favorite is point-slope form. So I'm going to choose either one of these. It really does not matter. I'm going to choose the first one. Should get the same thing no matter what. So y minus my y value equals my slope of negative 122 times x minus my x value. All right, now let me do a little bit of distribution. Negative 122 times x is negative 122x plus 2,806. Grab a calculator if you don't believe me. I'm really good at math in my head. Of course, I have this pre-done. I'm looking on my paper here. All right, now I'm going to add the 4,783 over to both sides. On the left side, they'll cancel out, and I get y equals negative 122x plus 7,589. So x is the amount of money I charge for my widgets. Got to make sure you define your variables. So this is the price per widget. And y is the number I sell. Now, the slope we already talked about, the slope is really easy to understand. It just means for every $1 more I charge per widget, I'm going to sell 122 less of them. Now, the y-intercept is also fairly easy to make sense of. It says if I charge $0 for my widgets, I'm going to sell 7,589 of them. Now, that actually doesn't make a whole lot of sense. Maybe that's like what I have in stock, maybe, or what I have in inventory. But if I charge $0, that would basically be giving away them for free. So maybe, again, 7,589 is how many I have, because if I'm charging 0, then I'm just going to end up giving them all away. Who's not going to take a free widget, right? But again, sometimes that y-intercept doesn't necessarily make sense there, but the slope definitely does. I have one more problem to go here in our modeling word problems here. So Jamal is choosing between 2 truck rental companies. The first, Keep On Trucking, charges an upfront fee of $20 plus 59 cents per mile. So just to rent the truck, you got to pay $20 and it's 50 cents per mile. So that's going to be his cost. And Move It Your Way is the second company. Their cost is $16 plus 63 cents per mile. So some people might jump at this first one because they're saying it's only $16 up front. I don't want to pay that extra $4. But at some point, the extra money you're spending per mile is going to make it actually a worse deal. So the question says, when will Keep On Trucking be the better choice for Jamal? So, if he's just thinking right up front, hey, $16 is cheaper than $20, then that might be the better deal in the beginning. But like I said, as the price per mile is a little bit higher, it's going to pay off to go with the other company at some point. So to solve this, it's really simple. All you got to do is set them equal to each other. So we're going to take the 20 plus 59 cents M and set it equal to the 16 plus 63 cents M. So we're basically set them equal to figure out at what mileage are they the same, where it actually wouldn't matter which one you're using. And then anything less than that, it looks like Move It Your Way will be better. Anything more than that, looks like Keep On Trucking is going to be better. So first I'm going to do subtract 16 from both sides. So I get a 4. Then I'm going to subtract 59 cents M, 0.59 M from both sides. Just kind of use my like variables here. And that's 0.04 or 4 cents M. Then I'm going to divide both sides by 0.04. That's pretty easy. And we get 100. Didn't even need to calculate for that. So after 100 miles, they are tied. Doesn't matter what truck company you use, 100 miles, it's going to cost the same amount of money. But anything over 100 miles, it's better to go with Keep On Trucking. Because even though the initial fee of the $20 is more money, you're actually paying 59 cents, which is a little bit less per mile. So with high mileage, the lower mileage cost is better. But if you are going to go less than 100 miles, then it's cheaper to go with Move It Your Way. Because yes, you have that cheaper upfront cost. You're not going as far as that 63 cents per mile doesn't hurt you too much. And you have the savings that $4 you save off the front. So anything over $100, it's going to be much smarter for Jamal to use Keep On Trucking. And again, solved all of this with linear functions. So those are a couple fairly simple word problems that you need linear modeling to understand.